Okay, in this section we're going to be doing some function operations, meaning addition, subtraction, multiplication, and division, and also we're going to do some composition of functions. Okay, so let's start with these few examples. We have two functions, f and g. F of x is 4x plus 8, g of x is 2x minus 12, and we want to do a few operations with them. So I'm going to show you how you can do all four of those basic operations of functions. Okay, so first one is telling me f plus g of x. What this really means is to take f of x and add it to g of x. F minus g of x means take f of x and subtract g of x, and so on. That's all this terminology actually means. So f plus g of x is already started for me. F of x plus g of x. So what is f of x? F of x is 4x plus 8. So that's what I'm going to put here. 4x plus 8. Plus, that's f of x. G of x, which is 2x minus 12. I add those two together, combine any like terms that I see. See the addition sign. Don't try to FOIL here, okay? This is not multiplication. This is addition. 4x plus 2x is 6x. And positive 8 and negative 12 make negative 4. There's my result. F plus g of x is 6x minus 4. Let's do the next one. F minus g of x. That means f of x minus g of x. F of x, once again, is 4x plus 8 minus g of x, which is 2x minus 12. And here you got to be careful, since I'm subtracting, this negative sign has to be distributed. So it's going to be 4x plus 8 minus 2x plus 12, because that negative changes the signs. And then combine like terms, and you're done, just like in the previous one. 2x plus 20. There's your result. So f minus g of x equals 2x plus 20. Okay. Number 3, f times g of x. So once again, all that means is take f of x and multiply it times g of x. F of x, once again, is the same thing we've been using, 4x plus 8. G of x is 2x minus 12. And now you're going to FOIL, because this is multiplication, so you need to multiply. 4x times 2x is 8x squared. 4x times negative 12 is negative 48x. 8 times 2x is 16x. And 8 times negative 12 is negative 96. Combine like terms and you are done. So it's going to be 8x squared, negative 48x, and positive 16x is going to be negative 32x minus 96. So that means that f times g of x is equal to 8x squared minus 32x minus 96. Alright, last one. F over g of x. That's a division, so we need to divide f over g. Okay, so what this really means is take f of x and divide it by g of x. F of x, once again, is 4x plus 8. G of x is 2x minus 12. Okay, if you can simplify, simplify. If it's not possible to simplify, you're good. Here, what I can do is divide both sides. On the numerator, factor out a 4. In the denominator, I can factor out a 2. Now, you might think nothing cancels, but here I have a 2 and a 4. So 2 goes into 4 twice. So your final result is 2 times x plus 2 over x minus 6. You can leave it like that, it's fine. Or you can distribute the 2 and leave it as 2x plus 4 over x minus 6. Those are your... Both of these are acceptable. F over g of x is 2 times x plus 2 over x minus 6, or 2x plus 4 over x minus 6. Okay, last thing we need to talk about this in this part. It says perform each function operation and find the domain of the result. Okay, so you need to find the domain of this. Find the domain of this. Find the domain of this. Find the domain of both of these. Okay, domain means what are the possible input values? What are the possible x values? Okay, Most of these are pretty simple. Whenever you have a linear function, or a quadratic function, or a cubic function, any type of polynomial function, the domain is going to be all real numbers. Because what we're saying by putting all real numbers is that any possible value of x is possible here. I can plug in, I can substitute in whatever I want. I can substitute in a 1, a 2, a 3, a 5, a 10, a million, a negative 1, a negative a million, fractions, decimals, radicals. I can put in whatever I want in here and something will come out. Okay? This is special. When you have a rational function, like a fraction right here, then there's an exception here. This number, whatever it is in the denominator, can never be 0 because you can't divide by 0. So we must make an exception. You can plug in whatever you want, except for a certain number. Okay? What is that certain number? Whatever makes this 0. You want to find out what makes that 0? All you're going to do is set the denominator equal to 0. I'm going to erase this one so I can do the work. The solution is the same either way. Set the denominator equal to 0. X minus 6 equals 0. Solve that and you get x equals 6. Now, this is backwards, right? It's not saying that x equals 6. It's saying that x cannot be 6. X must never be 6. So your domain is going to be all real numbers except for 6. All real numbers except 6. We can write it like this. X does not equal 6. And that pretty much says, as long as x does not equal 6, it's fine. Okay, let's try a few more of the same idea. Okay, so I have two different functions now. F of x is x plus 2, g of x is radical x minus 1, and I'm going to do these same 4 operations that I did before. Okay, so here you go. This one's asking me to do f plus g of x. That means f of x plus g of x. F of x is x plus 2, and g of x is radical x minus 1. What you do here is try to combine as many like terms as you can. So what I have is x plus radical x. I can't combine those two, they are not like terms. However, I can combine the 2 and the negative 1. 2 minus 1 is just 1. There's your result. F plus g of x is x plus radical x plus 1. Now the question again is, what is the domain? The domain could be any number that you want, but there's a big exception here. This radical x says that you cannot have a negative inside of the radical, right? So when you cannot have a negative inside of the radical, what you need to do to find the exceptions is set the inside of the radical, the radicand, set it equal to 0, okay? This one's pretty simple. Set that equal to 0, and you get x equals 0. So that is an exception, okay? That is your limit of what you can be. So what it's saying is not that x cannot be 0. X could be 0. You could plug in 0. However, you cannot plug in anything that is less than 0. You can't plug in any negatives in there. If you plug in negative 1, it doesn't work. But if you plug in 1, it works. Okay? So what is your domain? Your domain looks like this. X must be greater than or equal to 0. Because you cannot plug in a negative in there. It must be positive or 0. Alright, number 6. F times g of x. So that means f of x times g of x. F of x is x plus 2. G of x is radical x minus 1. We're going to have to FOIL here. X times radical x is x radical x. Don't combine them. You cannot put them together. Okay? X times negative 1 is negative x. 2 times radical x is 2 radical x. And 2 times negative 1 is negative 2. You can try to put these together, but you can't really do it that well. Okay, what we can do is put x radical x plus 2 radical x, and then minus x, which is by itself, and then minus 2. None of these are truly like terms. You can say, oh, this one has a radical x and this one has a radical x. If you wanted to put them together, you would write it like this. Okay. You would factor out a radical x from both of them, and you would have this, radical x times x plus 2. and then minus x minus 2. But you could say the same thing about these. You could put these together by factoring out an x from each one of them. So nothing really truly works out as a simplified version. I'm going to go ahead and leave it like this. Okay, this is f times g of x. X radical x plus 2 radical x minus 2. What's the domain here? As you can see, there's also radicals here. Radical, radical. That gives me the restriction, right? X cannot be negative. So once again, the domain must be x is greater than or equal to 0. For this particular one, x could be anything you want. But since these two have an exception, x cannot be negative. All right, let's do number 7. F over g of x, which means f of x over g of x. F of x is x plus 2. G of x is radical x minus 1. That's it. You really can't do much here, okay? This is as good as it's going to get. We might be able to rationalize the denominator by multiplying by the conjugate, which is radical x plus 1 over radical x plus 1. But we're going to be good here, okay? I just want to leave it alone so that we don't have to worry too much about it. So it's going to be f over g of x. But we do have to find the domain. Now the domain here comes from the denominator, right? This cannot be negative by itself, and the whole thing cannot be 0, okay? So let's do the 0 one first. This whole thing cannot be 0. It can't be 0, because otherwise it doesn't work. So what would make this 0? Add 1 to both sides. What would make it 0? If I square both sides, I get x 1. If x was 1, if x were to be 1, then this would be 1 minus 1, which is 0. So x cannot be 1. That's the first exception. What's the other exception? The other exception is that x cannot be negative, right? Once again, because there's a radical. So x must be greater than or equal to 0. There's 2 exceptions, okay? So x must be greater than or equal to 0, but it cannot be 1. Okay, so x could be anything between 0 and 1, and anything bigger than 1. Okay, yeah, I can think of a bunch of numbers: 1/2, 1/4, anything between 0 and 1, and then anything bigger than 1, 2, 3, 4, 5. Okay, that's your domain. And finally, number 8, g over f. This one over that one, right? G of x over f of x. G is radical x minus 1. F is x plus 2. And that's it. You can't do much else. Nothing cancels here. Don't try to cancel anything. Okay? What's the domain? The only exception, the 2 exceptions come from this and this, right? Let's start with this one. This cannot be 0. It cannot be 0, which means that x cannot be negative 2. X does not equal negative 2. That's your first exception. The second exception is that x must be greater than or equal to 0. Alright. If x must be greater than or equal to 0, could it ever be negative 2? Alright, this is saying that x must be positive. So if x must be positive, that means there is no danger that x is going to be negative 2. I don't have to write that one because it's already covered here. In this one, I do have to write both because it's saying x must be positive, but except 1. Okay, so this is your domain. Just this piece right here.